Good morning. The question for today is prove that this equality is not there. Okay, sine 5x minus 2 sine 3x plus sine x upon cos 5x minus cos x. See here the grouping is important here. I will write sine 5x plus sine x, then I will take minus 2 sine 3x later. See this one, I'm going to apply a formula, and the denominator cos 5x minus cos x. Okay, I'm going to apply the formula for sine 5x plus sine x, that is 2 sine 5 plus 1 6x by 2, and then cos 5 minus 1 4x by 2 minus 2 sine 3x is as it is, upon here we are going to apply cos c minus cos d, that is minus 2 sine 5 plus 1 6x by 2, and then again sine 5 minus 1 4x by 2. Okay, so finally what I'm going to get is 2 sine 3x and cos 2x minus 2 sine 3x is in the numerator, and in denominator minus 2 sine 3x and sine 2x. Here what I can take common, 2 sine 3x I can take common. I will take 2 sine 3x common. I will get cos 2x minus 1 upon minus 2 sine 3x into sine 2x. Okay, now this one 2 sine 3x will get cancelled. Yeah, very important thing is a minus sign is here. I'm going to take it in the numerator. I will be getting 1 minus cos 2x upon sine 2x. Okay, we end up till here. Now cos 2x, we have three formulas, but what I'm going to use here is 1 minus 2 sine square x. I'm using this formula for cos 2x. Okay, I'm converting into sine. Now what about sine 2x? There is only one formula, that is 2 sine x cos x. So when you remove the bracket, I'll get 1 minus 1 minus or minus plus 2 sine square x upon 2 sine x into cos x. So this 1 and 1 gets cancelled, and what is left over? Let me write another step. I hope you got the answer, but still 2 sine x and cos x. Here 2 and 2 gets cancelled and 1 sine x will cancel. Finally you will get tan x.